Welcome to my teaching channel again. This video covers cross-tabulation and measures of association for two discrete variables in Stata. Before we start, make sure that you have two files ready on your desktop. The first one is the gss2014.dta. This is the data that we are going to use. And another one is called Crosstabulation and Measures of Association.do. This is the do file that we are going to demonstrate basic features of crosstabulation and measures of association in Stata. Once you have these two files on your desktop, double-click on Crosstabulation and Measures of Association.do to launch Stata. We have three learning goals for this video. Number one is some basic feature of cross-tabulation for two discrete variables. And then we move on to the topic of statistical independence and a chi-square test for statistical independence. Finally, we talk about some commonly used measures of association between two discrete variables. First of all, point to the working directory of the desktop. Let's highlight row 16 and click on the do button to run the command. And next, let's open a log file. Highlight row 19 and run. Then we launch the data gss2014.dta. Highlight row 22 and run. So if you switch back to Stata, you will see that the GSS2014 data has been launched to the memory. Let's list the frequency distribution of two variables of our interest. The first one is the biological sex of the respondent, variable sex, and another one is the measure of the trust towards other people. So in order to see how these two variables are coded, we include one additional command on row 25, num label, comma, space, add, so that we will see the value label as well as the coding scheme of the two variables at the same time. So how about we highlight three rows from row 25 to row 27 and click on the do button. It will take some time to run the num label command because it's going to change the value label of all the variables in our memory. This is the result. We see that respondent's sex, biological sex, was coded by one male and two female. So totally we have 2,538 cases. For the variable trust, it measures can people be trusted. For this variable, it contains three levels. 1, can trust. 2, can't be too careful. 3, depends. So it looks like that this variable trust contains three different categories. To ease our analysis, we are going to recode this original coding of trust into a dummy variable called trust_d, which contains only two values. 1 means that people can be trusted. 0 means people cannot be trusted. So the only thing we need to change is to combine the original coding 2 and 3 together into the new value 0. And then we generate a new variable called trust_d. D here refers to dummy. And then once we have a new variable, we need to give a variable label to this new one. So what do you mean by trust_d? It means can people be trusted? And then we need to define a new set of value labels, where 1 means yes, 0 means no. Finally, we attach this new value label to the new variable trust_d. Since we just generate this new variable, so we need to run num label this command again so that we can see the coding scheme as well as value labels at the same time in a new frequency table. So how about we go ahead and highlight the rows from row 29 to row 35, and let's see the recoding result and the distribution of a new variable trust trust_d. You may need to wait a while for num_label command to run. And once it finishes, you will have a frequency table for our new variable, and trust_d. Can people be trusted? No, coded as 0, and yes, coded as 1. And our core mission today is to draw a cross-tabulation for two variables. And here, a very basic idea for cross-tabulation is that this is a technique for you to seek for a relationship between two discrete variables. What I should emphasize one more time is the type of the variables. You need to use this technique only to two discrete variables. Usually we don't use cross-tabulation for continuous variables. That's something that you need to remember so far. So for a cross-tabulation, it's actually a squared or rectangular table for the distributions of two variables at the same time. So how about we highlight row 37 and see the basic feature about cross-tabulation. Highlight row 37 and click on the Do button. And then we switch back to the output window. You will see a cross-tabulation. This kind of table is commonly seen on mass media. It demonstrates the combination of totally 4 different situations. Males who say no to this question, males who say yes to this question, females who say no to the trust question, and finally, females who say yes to this trust question. So we have 4 frequencies in totally 4 cells in the middle of the cross-tabulation. It shows you 4 different combinations of 2 variables. We also have 2 row margins as well as 2 column margins for this cross-tabulation. Row margins add up 2 frequencies on the same row. So there are totally 754 male respondents to this question, and 929 cases, female cases, to this question. And putting these two together, we have totally 1,683 valid cases who provided valid answers to both of these 2 variables. Similarly, if we add up 2 frequencies for each given column, we will have column frequencies. For example, totally we have 494 males say no to this question, and 670 female cases say no to this question. So totally we have 1,164 cases saying no to can people be trusted. Similarly, we have 260 male cases saying yes, and 259 female cases saying yes. Totally, we have 519 cases show very high level of general trust. And if you add up these 2 column margins together, you will reach the total sample size of 1683 one more time. This is some basic features about a cross-tabulation. In addition to seeing these absolute frequencies, cross-tabulation gives you a very handy feature to calculate percents, or say percentages, so that you can have a better view of the relationship between 2 discrete variables. There are 3 different ways to calculate percentages from raw frequencies from a cross-tabulation. Generally speaking, they are row, column, and cell percentages. Let's explain the meaning of each one. First, we can calculate something called the row percent. So how about we highlight row 42, which is the same command, tab followed by 2 discrete variables separated by at least 1 space, and an option called row. So highlight row 42 and click on the Do button. This is the output. So for row proportion, we treat the row margin as 100% and distribute this 100% according to the proportion of two row frequencies. So here we treat 754 male cases as 100% and then distribute this 100% according to the proportion of 494 to 260. So it's clear that for all males, 65.52% of males say no to this trust question, and 34.48% of males say yes to this question. We treat 929 female cases as 100% and distribute this 100% according to the proportion of 670 to 259. So totally, we have 72.12% of female respondents who say no to this question, while we have another 27.88% of females say yes to this question. So this is the output and explanation of row percent. Following this idea, we can also define something called a column percent. So how about we go ahead and highlight row 43 and click on the Do button. In the output, you will see that this time we treat the total of each column as 100% and then distribute this 100% according to two frequencies in the same column. For example, we have totally 1,164 cases who say no to this trust question. So we treat this as 100%. And then we distribute this 100% according to the proportion of 494 to 670. That means for this no column, there are 42.44% of male respondents and 57.56% of female respondents. Similarly, for people with very high general trust level, totally we have 519 cases of them. We treat this column margin as 100%. So it looks like for the people of very high level of general trust, 50.10% of them are males, 49.90% of them are females. This is the output and a brief explanation about column percentages. Cell percent, or say overall percentages. It treat the total sample size as 100% and distribute this 100% according to the frequencies in 4 cells in the middle of this cross-tabulation. So let's highlight row 44 and click on the Do button. And this time, the total sample size 1683 will be treated as 100%. And then this 100% will be distributed according to frequencies in these 4 cells in the middle. It looks like we have 29.35% of males say no to this question, 15.45% of males say yes to the trust question, 39.81% of the cases who are female and saying no. Finally, we have 15.39% of the total cases who are females and saying yes to this trust question. So this is the output and a brief explanation about cell or say overall percentages. There's an additional definition that's very important for cross-tabulation. It's called degree of freedom. Degree of freedom for a cross-tabulation is defined in this way. The degree of freedom equals to how many rows minus 1 times how many columns you have in this cross-tabulation minus 1. So for my current example, we have 2 categories for respondents' biological sex and 2 categories for this general trust question. So totally we have 2 rows and 2 columns. So the degree of freedom for this cross tabulation will be 2 minus 1 times 2 minus 1, which is 1. So what do you mean by degree of freedom? So if we list this cross tabulation one more time, highlight row 50 and 1, you will see a table like this. If we maintain this 4 margins, 2 row margins and 2 column margins, and the total sample size unchanged. And let's get rid of the numbers in the middle of the table. Now, you randomly pick a cell and assign a number to it. Once you give a number to any randomly chosen cell of this 4, then the frequencies of another 3 cells will be fixed. That means you can only freely change number of one cell. Given row and column margins, another 3 frequencies in another 3 cells will be fixed. So the degree of freedom is therefore 1. So that's the meaning of degree of freedom. So if you have a cross tabulation with 3 rows and 2 columns, then the degree of freedom will be 3 minus 1 times 2 minus 1, which is 2. So how about we highlight row 54 and 1? This is the cross tabulation between race and level of general trust. You will see that we have 3 categories for the variable race and 2 categories for the variable trust. There are totally 6 cells in the middle, and the degree of freedom for this table will be 2. Keeping those 3 row margins and 2 column margins unchanged, you can only freely change 2 frequencies out of 6 frequencies. Once you define the 2 frequencies out of 6, then another 4 frequencies will be fixed. That means the total degree of freedom is only 2. That's the meaning of degree of freedom. This idea is important because degree of freedom will be used in the following topic about statistical test of independence. So we will talk about statistical test of independence in the next video. Thank you for watching.